All right. So as far as our review of linear functions, there's a few things that need to be made like completely clear. Right? When we're dealing with a linear function, there's always the two main parts. All right. And those things are the rate of change, otherwise called the slope from time to time, and the y-intercept. In a context, this is sometimes called the start value because it's where we start on the y-axis. So in a linear function, we always have these two things, right? It never changes, never goes away. We have two different types of rules that we have worked with. There is the symbolic rule, which there's actually multiple symbolic rules for a line. We have only been working with the slope-intercept form. And that is y equals mx plus b. This is our symbolic rule. It's a slope-intercept form. We also have called the now next rule. Right. And this actually uses the words now and next to describe how things are changing and where they start. In a now next rule, it's common to just start with now, and then you will add or subtract the rate of change depending on if it's a positive or negative rate of change. In this case, we'll just say plus m, so that we're using the same letter as we use in our symbolic rule, kind of make a connection between these two things. So we have now plus m equals next starting at whatever the value of b is from our symbolic rule, which is also the y value of the y-intercept or the start value. So we have these common parts within both rules. All right. So again, the m is our slope or rate of change. All right, and b, you can think of that as the start value or the y value of the y-intercept. And those are the same things over here. We add the rate of change to now. And we start at the start value. Okay. What can I clarify about these things right here? So then we also represent linear functions with graphs. Right? Let me move my graph. All right. So in a graph, right, the up and down line, right, the one that's going vertically is our y-axis, horizontal is x. Right? There are the two main types of lines we've looked at have been lines that go increasing in value. Right? We can also have lines that are decreasing in value, which we've also seen. Scrolling. That's better. Right? Changing my graph. I want to change my graph. Right. So we have y and x with a line that is like we also have decreasing lines, increasing lines. The graph to the left here, right, the increasing graph, this is increasing. Right, when we go from left to right. This means if we see this type of graph, it's increasing from left to right, we automatically know that the slope is positive. It is increasing, our slope is positive. It's being added. In the case over here, where we are decreasing, from left to right, this automatically means that the slope is negative. Okay. So we have slope being positive or slope being negative, and we can tell that just by looking at the graph. We get information. All right. We can identify points. Okay, so like this is our y-intercept. We have an x-intercept, y-intercept, an x-intercept. The y-intercept is the one that's the most important when trying to figure out the rule for a line. There are times where we'll need the x-intercept, but that's what we're getting to starting next week is what's the importance of the x-intercept. We'll get there next week. But for now, when we're focusing on representing a linear function and using a rule, we need the y-intercept. That's the important value that exists on our line right here. Okay. And again, we can see our rate of change on a graph by looking at what do we change in x and what do we change in y to get from one point to the next going left to right. Right? We have a change in x and a change in y. Right? On our graph to the left here, where we're increasing from left to right, we have a positive change on x, and we have a positive change. The little triangle just means change on y, which means positive divided by positive, that gives us a positive slope. Right? Going from left to right here, I have a negative change on y, but a positive change in x. A negative divided by a positive will give us a negative number. That's why we always know that when we're decreasing from left to right, we have a negative slope. Okay. What can I clarify? What questions do you have? So again, the graph, our rate of change always equals the change in y divided by change in x. Okay. Thank you for letting me know, Ariana. No worries. Okay, so again, rate of change, change in y, change in x, and we can find the y-intercept just by looking at the graph. So we have our points, the things we need, right, to write the rule based on a graph, given a graph. Okay. Now, we also have tables. Right. When given a table, we're usually given, there's two types of tables, okay? The most common one we've seen so far is just a table that we reread from left to right. We can have an x variable and a y variable, and then we have numbers in our table. Sometimes it will start with 0. I could start with a negative number, depending on the table it's referring to. You know, it can be something as simple as 1, 2, 3, 4, 5, 6, 7. And maybe this starts with 3, 5, 7, 9, 11, 13, and 15. Great. So we have a table of values this way. We can also show the same table as what's called a t-table, which we've also seen, where the table is written vertically instead of horizontally. And typically x is written on the left and y is written on the right. But it's the same information, it's just kind of like switched in like the direction that it's facing. Either of these representations will give us the same results. We can still find the rate of change, and we can still use the table to find the y-intercept and the start value. The way that I like to illustrate this, which is what I've done in class with you guys already, is I use the little arrows, right? and we go, okay, well, we're changing +1 here, +1, +1. Right, all of these are +1s. And we can see the same thing over here, +1, +1, and so on. A rate of change always has to be for 1 unit of change in x. What's the change in y? That's what we're ultimately finding. We already have just a single change in x. I'm changing +2 in y. And so regardless of which type of table I use, we'll get the same rate of change. For every 1 unit change in x, we get a 2 unit change in y, right? Which means the rate of change in this table is just 2. If my numbers aren't as friendly, right? Maybe the x values I'm given don't go up by 1 every time, they're kind of jumping around. That's when we just pick 2 points and do the division. Same as we use division up here, change in y divided by change in x. We can do that same thing, right, with 2 points, and it will give us the rate of change for a table that's not so friendly. We just pick 2 points, change in y divided by change in x, it will give us the slope. Here, which are the same table, don't show our y-intercept. Right? We need to go backwards to get there. Right? I need x to equal 0 and find out what's the value of y. So I have to go backwards. Subtract 1 to get to 0 here, which means I subtract 2, 1 rate of change, to get to the y value of 1. Okay, that means the y-intercept is the coordinate 0, 1, right? And the start value is just 1, the y value of the y-intercept. Okay. Between these things, we can now write the rule because we have all the parts. We can write this rule, our symbolic rule. Is y equals 2x plus 1. We have all the information necessary. Right, we could write the now next rule. That would be now plus 2 equals next, starting at 1. Right, what questions do you have? Lastly, we have context that can also be used to represent a linear function. We've seen there's 2 basic types of context that we'll get. There's one where we're kind of given our rate of change and our y-intercept within the context, and there's context where we'll only be given points that are on the line. right? So we can have, for example, we can say, Jenny is a babysitter. And she charges $10 as a flat fee, and $5 for each hour of babysitting. Right. In this case, the $10, which is the flat fee, is a starting value, right? And the $5 for each hour is the rate of change. And our rate of change is 5, and our start value is 10. And that's just in the context. We just need to pull out those numbers and identify which one is which. The $5 is attached to every hour, so that's the rate of the hours build up. It makes her get paid more. The $10 doesn't change. It's always a $10 flat fee. It doesn't depend on anything else, so it's just the start value. We could have the same, babysitter, and she's maybe trying to find out what's the best price. Right? So she says, okay, well, so we'll have Jenny, again, as a babysitter. And is testing different prices to charge. All right. When she charges $12 per hour, she gets, say, 5 clients a week. When she charges $15 an hour, she gets 3 clients per week. Right, so this is a different type of context where I'm not directly given the rate of change in the start value. I'm given 2 points. Right, so we have 2 sets of coordinates existing in here. We have $12 an hour and 5, and we have 15 an hour and 3. So this gives us coordinates. All right. The pay, how much she charges, affects how many clients she has. So the pay becomes the X variable. We have a coordinate of 12, 5, and a coordinate of 15, 3. So then we can use the 2 points to find our rate of change. And then we can do some extra math to find our y-intercept. Right, so the rate of change, we need our change in y divided by change in x. In this case, the change in y is 5 to 3. That's a minus 2. Divided by change in x, 12 to 15, that's a plus 3. Right, so we have negative 2 divided by 3. Negative 2/3 is the rate of change. It's our slope. It's a negative slope. Okay. To find the y-intercept, we pick a point, do 12, 5, and solve for b. We set up the equation like this. When we do negative 2/3 times 12, get, let's see, negative 24 divided by 3, negative 8. 5 equals negative 8 plus b. Right. We can add 8 to both sides to finish solving this. 5 plus 8 is 13 equals b. Negative 8 plus 8 cancels. So we end up with the rule y equals negative 2/3 x plus 13. So there's these two different types of contexts that we'll have. This one we end up with the rule y equals 5x plus 10. What questions do you guys have? What can I explain? What can I clarify? Yes. All right, so Eileen is asking if I can explain the 5 equals negative 2/3 times 12. All right, and the negative 2. Okay, so let's do a little, let's show some extra stuff here. I'm going to draw a little line here so that I can work on this one. So we have these two coordinates. All right, let's call this one A and this one B. Coordinate A is at 12, 5, which means as far as like the x-axis goes, it's farther to the left than coordinate B. All right. So on our like XY axis here, 12, 5, let's say 12, 5 is going to be, let's just guess that it's somewhere over here. I'm not putting numbers on here, and this is just so we can kind of get an idea of where things are. 15, 3 is going to be farther to the right, but lower. Let's say like right here. So between these 2 points, we find the rate of change by doing the change in y, right, from here to here, and the change in x. Right. In this case, the change in y from 5 to 3, right, this is y and this is y over here, is minus 2. To get from 5 to 3, we have to subtract 2. The change from 12 to 15 right, our x value here, we have to add 3. So these numbers are what go into our calculation for the slope. Right, we have the -2 here and the +3 as the denominator. Because this is our change in y. Right, and then we have our change in x +3. So that is what gets us our slope of -2/3. Right, so then when I need to find b, right, I need this value. This value of b tells me, right, where I'm going to cross the y-axis, which is like, I could be able to draw a very straight line here, but I'll try. Of course, I'm not going to do that. Sorry, guys. And it's close. We'll call it close. So we have our y-intercept here that we need to find. At this point in the problem, we don't have it yet. We find out that it's 13 by doing the math. And to do that, we just pick one of the two coordinates and replace x and y in the unfinished formula with those values. Right? So this is x and this is y. And I want to use right there. Right? The 5 replaces y and 12 replaces x. Right? In our unfinished formula that I don't have b for yet. When you do -2/3 times 12, right, you get -24 divided by 3, and -24 divided by 3 is -8. That's how we got this -8 down here. And so essentially, what number do you add to -8 to get it +5? You have to add 13 to -8. Kind of an easier way to do that is to reverse the operation and do add 8 to this side, but if I do it to this side, I have to add it to the left-hand side. When I add 8 to the left-hand side, I get 13. When I add 8 to the right-hand side, I'm left with just b because -8 plus 8 is 0. And so then we find out that this right here is at 13. Okay. Does that answer your guys' question, Jocelyn and Eileen? Right. And yeah, this type of problem where we just have coordinates to start with has the most work, right? That's the most like math for these types of problems, is when you just have coordinates to start with. Okay. All right. You're welcome. So now let's do some practice. All right. So does anyone need any more time to write anything down from the notes? Okay. Remember, the notes will be available in Canvas. And so now, let's hope that all my stuff works. All right, let's see if this cooperates today. Click. Doesn't want to click. There we go. Alrighty. Gonna start. All right, so once again, I'm gonna put the link in the chat. Please click on the link for the Pear Deck and join. Right. Please use your school email and password to do so. If you're having any issues joining, please tell me. Put it in the chat that you're having issues, or just unmute your mic and say that it's not working. All right, looks like we're up to 5. And guys, please remember, you will get some credit today in the gradebook for participating in the Pear Deck. Doesn't matter if you're getting right answers, wrong answers, left answers, right answers, whatever. For participating, you will get some credit. Okay. So, Ariana, if your Wi-Fi is just not letting it happen, just continue to follow along through Teams. Okay. So yeah, just follow along through Teams, because I'll be sharing the questions, like the slides and everything on Teams. I'm still sharing my screen. So you'll be able to see the questions. And if you like, you can just type your answers into the chat for me, and I can look at your work that way. Okay. All right. We get about 30 more seconds to see who else joins. I know that there are more than 15 students in this room right now. I do believe there's, let's see how many. This says 27. So I'm missing 10 students still. It's not 17. All right, guys, we're going to start. All right, so again, we're looking at representations of linear functions with graphs, tables, rules, and contexts. All right, here is the first question. Use your mouse to circle the y-intercept on this graph. The y-intercept, not the y-axis. Whoa. I know it's not going to circle perfectly, but like if you just put like a mark or something right where as close as you can get to the y-intercept, that will work. And you might, I don't know if you guys can change the thickness of the line you're drawing with, but that might help as well. It takes 30 more seconds to get your response. Alrighty. So you should have circled a point that was at the coordinates of 0 and -2. Right. Next question. Right, and that's the point that I've circled here. So there you go. There's a freebie there. If you guys are listening and paying attention, I already told you what the coordinates of the y-intercept are. Please be sure that your response is written as a coordinate, so it should be in parentheses. All right, it should be inside parentheses. Right. This is very good work so far. Please make sure, I'm leaving some of you guys little comments within your answer area, so please make sure to look at the comments that I leave for you if I've left you some. Excellent. All right. All right. So the proper coordinates would be the coordinate of inside parentheses 0, comma, -2. We have an x value of 0 and a y value of -2. I think we have that here on our next slide. So here we need to use the 2 points indicated on the graph to find the rate of change for the line. So we will be using the change in y divided by the change in x. Remember, we're doing the change in y divided by the change in x, moving from left to right. So you might want to figure out to go from -2 to +4. What do you need to add to y? You go from 0 to 2. What do you need to add to x? You will divide those two numbers. Okay, Eileen, give me just a moment. Nicholas, I just gave you some feedback in your response on Pear Deck. Seems like this one's giving us a hard time here. All over the place. If you guys want in Teams in the chat, I just gave a very good hint. So you might want to look over at that real quick and see if that helps. I mean, so yes, I do understand what you mean. You can just count the spaces, so to say, to find the rate of like the change in y and the change in x. Yes, Camila, I just left you some feedback to your response in Pear Deck. All right. See. All right. Let's see if I can do. All right. So the correct answer was 3. 3 is our rate of change. For every 1 unit change in x, I go up 3 in y. Between the 2 points on this graph, we're doing 2 units of change in x, which means we have a 6-unit change in y. 6 divided by 2 is 3. All right. So and we can also see that since the line is going up, it's increasing from left to right, the slope must be positive. Right? So we know right away that our slope is positive and it's, going up, right? And so then we just need to find the change in y and the change in x. Right. Right. So far for this graph, we have the y-intercept at 0, -2, and we have the rate of change, which is 3. So don't worry about it, Eileen. We review this so that we can like kind of get better at finding our own mistakes at times, right? Because arithmetic errors are kind of the most common errors that happen. It's not done on purpose. It's not because you don't know what you're doing. It's just an error. So don't stress on it too much. All right, so let's go to our next slide. Next question, right? Based on what we've done so far, we're going to write the symbolic rule, the y equals mx plus b form, for the line on the graph. So in that rule, remember, we're replacing m and b with the values that we've just discovered. All right. Let's see. All right. All right. So for many of you, I've left you some feedback. If you want to look at that, please do. Click back in the conversation. What's going on here? That's okay, Nicholas. No worries. So, okay, first, the correct rule, right, would be y equals 3x minus 2. Type it in the chat as well. All right, it's going to be y equals 3x minus 2. The slope, or the rate of change, goes with the variable of x, right? Because it's multiplied we multiply by x, whatever value x is, for every unit we move over. And the y value of the y-intercept of -2 is, the last part of that, -2. If it was a positive y-intercept, it would be, like if we were at 0, 2, then it would be 3x plus 2. If you wrote y equals 3x plus -2, that's technically still correct. It's just more conventional if you're adding a negative, saying plus -2, to just write -2. Okay. So, and again, we get this by kind of filling in the blanks, so to say. The rule, the form of the rule is y equals mx plus b. Once we know the slope, which is m, it's represented by m in that general rule, we replace m with the value of the slope. Once we know the y value of the y-intercept, that value replaces b. Y and x stay put. They don't move. They stay there. We need them. So you end up, in this case, with y equals 3x minus 2. What else can I clarify for you guys? What can I explain further? And I was like, if you wrote y equals x3 minus 2, that's still technically correct. So x times 3 is still good. Why is it minus 2? All right, so Destiny is asking, why is it minus 2? We get the minus 2 at the end, right? Because we have a -2 as the y value of the y-intercept. Okay? That is the number that goes in for b. Right, so if we just straight replace it, we get that y equals 3x plus -2. However, when you add a negative number, you're just subtracting the number. Right, so plus -2 is the same as saying -2. Okay, and so the -2 we have comes from the y value of the y-intercept, that -2. Which then translates to -2 for b. Does it answer your question? Cool. Excellent. Alrighty. Let's see here. All right. So we're at an hour and 10 minutes already. Okay, so I do have more of these. I've got a bunch more slides in this pair deck. However, we are over an hour right now, and that's a little bit more than we typically go. So I'm going to give you guys the option to continue doing the pair deck or leaving, I suppose, is the way we can put it. However, before you choose and before you leave, I do want to show you the self-assessment. So we're going to take a quick break. So please, I'm still sharing my screen. So if you can switch your tab so that you're looking at Teams, if that's something you can do, I'm going to share my screen so I can preview with you guys the self-assessment and explain to you what that is. Okay? So real quick. We're going to go into our modules. We're going to look at week 8. Right. And we're looking at our representing linear functions self-assessment. Okay. It is listed under Thursday. This is our first self-assessment. There will be more. All right, this is done in the form of a quiz, and that's because it's kind of the easiest way for me to keep track of you guys doing it. And it's easy for you guys to find. We have some directions up here. There are 3 parts to the self-assessment. All right, the first part, you need to answer the free response question as a demonstration of understanding of the content we've covered about linear functions so far. You can use any notes, resources, and calculator. I've got the link to Desmos right here to complete this problem. For the second part, please reflect on your learning over the past few weeks and answer the reflection questions. For the third part, you need to decide what level of understanding you currently have for the content we have been covering. To do this, you'll need to use the provided rubric and then select your level of understanding by using the provided checkboxes. These are the directions. Let's see what it looks like. Yeah, the directions are at the top of the screen as well. So we have our free response question. This is the question that you guys need to answer. And you'll just answer it using the provided text box. If you want, with the text box, you can upload a picture, right? So if you want to do this on a piece of paper and then take a picture of it and upload the picture as your response, that's fine. You can do that. You don't have to type it in if you don't want to. It depends on just what's easier for you to do. So we have our context here. John and David both participated in a 3-hour walk to help raise money for the local animal shelter. The graph below indicates the distance each person walked as a function of how long he had been walking. So we have our 2 graphs with the 2 lines. All right, if John walks faster than David, which graph would correspond to John's walk? Explain your reasoning. And number 2, find the slope of the line of line 1 and explain its meaning in terms of time and distance. That means like, okay, so based on the slope, for each unit of time or for however many minutes, how much distance is walked? What does your rule tell you about that? Right, and that's it, that's the problem. Then we have our reflection, right? Reflect on your learning and experiences over the course of this chapter and since school started. What was helpful to your learning? What would have helped you? What would you do the same or different if you're starting this chapter over? That should be started. I have some typos, sorry guys. And just answer this honestly. This is to help you reflect, but it's also to help me consider what things I can do differently. So please be honest. I'm not going to go like telling people that you're saying mean things to me or anything. If you have just some genuine feedback of stuff didn't work, tell me, please. It helps. Trust me. And lastly, we have our rubric. All right? This is a 4-point rubric, so you have to place yourself somewhere in the rubric. You cannot do a half. Okay, it must be a 4, 3, 2, 1, or 0. If you're doing this, if you're simply completing this assignment, you're not at a 0. All right, you are definitely above a 0 because you are trying this assignment. All right, so a 4 exceeds proficiency. You have an advanced understanding of the content. You'll understand it well enough to teach and explain it to others. The work that you have completed for this chapter has little to no errors. Okay, so the stuff that you have done previously should support the grade that you're checking 4 here. Right? We have this 3, you have a basic knowledge, you can do the work, you have some errors. A 2, you kind of get the foundations, but you're really still kind of struggling with how to apply it. Right? The 1 is you really need someone to walk you through it every step of the way to do it, to get it. A 0 is you didn't do anything. Really, the only way to do a 0 is not do anything. Right? Once you've decided where your level of understanding is, the checkboxes to choose your level of understanding. The way I have this set up, if you believe you're at a 3, you need to check 3, 2, and 1. It adds up the points for me, so it shows that that's what you've selected when I look at the gradebook kind of thing. Right? If you're at a 4, you check 4, 3, 2, 1. Do not check 0. 0 is what will subtract the point, right? It's counted as incorrect. All right, so that's how we'll use the checkboxes. And then once you're done, you've done all your responses, you'll say submit, and you're done. That's the self-assessment.